A very good morning to all the participants. Welcome back to our course on the C programming language. In today's session, I am going to discuss about the types of pointers. So in the last session, we have seen what a pointer is. We have briefly gone through what types of pointers that are available in the C programming language. We have seen the various operators that we deal with these pointers. And we have seen the declaration part of a pointer. And in today's session, our point of interest is the various types of pointers that are available in C. As we have discussed in the earlier session that we have different types of pointers like integer pointer, character pointer, float pointer, and null pointer, void pointer, dangling pointer, and we have pointers to arrays. And we have pointers to functions also. And we have pointers to the user defined data types such as the structures or unions. So these are all the various topics which I am going to discuss in today's session. We'll see how we can declare an integer pointer and what this integer pointer is. Similarly, we'll see what this character pointer is. All these things we will discuss. Let us start our discussion with the declaration part of the pointer. In the previous session, we have seen that the declaration of a pointer consists of three parts. The first part is the data type of the pointer which you want to declare, and then we have the asterisk symbol, and then we have the identifier. This is the syntax. Now let us take an example of declaring an integer pointer. So I want to declare integer pointer, therefore the data type is the int followed by indirection operator, and let me take the identifier as p. When the compiler comes across this statement int star p, it will come to know that p is an identifier which is of type pointer, and that pointer is pointing to integer. So in simple form we can say that p is a pointer of type int. So I read like this: p is a pointer of type int. Now the point here is this pointer to integer type. Very important discussion we should have. What do you mean by this pointer to type int means? This pointer, as I told, that it is not going to store the values. It is not going to deal with the integer values or floating point values. A pointer is a variable which can store the address of another variable. And when I say that p is a pointer of type int, so this p variable is going to hold the address of another integer variable. Very important point. That is the reason why we call p as pointer of type int. So p is going to hold the address of another integer variable. So I can write like this: p can hold the address of another integer variable. Very important point. So when I say that p P is going to hold the address of another integer variable, so there should be another integer variable. Let me take the another integer variable as n like this. When the compiler comes across this statement, it will declare or it will allocate the memory which is equivalent to 4 bytes according to 64-bit architecture. 4 bytes of memory will be allocated, and they will give the common name for 4 bytes as n. They means compiler. So we can assume that this is 4 bytes. And assume that the base address is 100. Always remember that this 100 what I am taking here is just for our making our understanding very easier. But in general, we know that the addresses of the memory locations will make use of the hexadecimal notation. Since to deal with the hexadecimal notations is somewhat complex, we just make use of these formal notations, which is 100, 200, 300. Please make a note of this. When the compiler comes across this first statement, int n, it is going to allocate the memory on the stack. Why? Because this is a local variable, and 4 bytes of memory can be called with a common name which is called as the identifier or n, and it is having a base address. Base address in the sense it is the starting address. Base address is 100 for these 4 bytes. So this will be 101, this is 102, and this is 103 byte. And let us assume that the second statement is a pointer declaration. Let me take the pointer declaration like this, int star p. You can observe here that the second statement is also a declaration statement. And we know what happens in the declaration. The C programming language allocates memory at the time of declaration only. And here it is going to allocate 4 bytes of memory. I will discuss why these 4 bytes of memory is allocated and what happens if you declare a character pointer. All these things we'll discuss, but right now you just remember that since p is an integer pointer, it is going to allocate 4 bytes of memory. And remember that these 4 bytes of memory, they can be called with the common name p, pointer. And let us assume that the base address is 200. So 4 bytes, this is 201, this is 202, this is 203, like this. This is how the pointer is going to, memory is going to be allocated for the pointer as well as the normal variable. So for our understanding purpose, let me represent these 4 bytes as a single block like this, and these 4 bytes for n as a single block like this. So this is n, base address is 100, and this is p, base address is 200. Since p is a pointer, I just want to distinguish this normal variable block with the pointer variable block, that I just put this p a small arrow. This is just for our understanding purpose. There is no notation, no thumb rule, no hardcore rule is there. So I distinguish the memory locations of the normal variables and the pointers with a small arrow. The pointer is represented with a small arrow. And this is garbage, and this is also garbage at this particular point. Now what I want to do is, I want to assign the address of n variable, which is of type integer, to a pointer variable p, which is of type integer pointer. We know what type of assignment operator we should use for assigning the value. It is nothing but an assignment operator. So I want to add, I want to store, I want to assign the address of n. So I take like this, address of n to the pointer variable p. So this should be our third statement. So look at this statement. So P is equal to address of n. We know what operator it is. It is address of operator which gets the address of a particular variable which is given beside of it. So address of n. What is the address of n we have? This is 100. And I am assigning the address of n to P. Is it correct or not? Yes, it is correct. Why? Because we are assigning the address of a variable to a pointer, and we know the definition of pointer is it is going to store the address of another variable. So the address of n is 100 and I am storing this 100 inside this P like this. Let me change the color, and this is 100. When this statement is executed by the compiler, what happens is this address of n is going to be stored in P, and we can say that we have a arrow. We can assume that an arrow is pointing to this n. An arrow is pointing to this n. That is the reason why we call this as pointers. So P is pointing to n. How we have made this P point to n means by this statement, by this assignment operator and the address of the variable. Very important point. So this is how we are going to deal with the integer pointers. So only 3 statements. Let me write it clearly here. Int n, and then we have int star P, and then P is equal to address of n. So these 3 statements, when they are executed sequentially, we are making the pointer P point to n. Right. We can combine these 2 statements, nothing wrong in it. For example, I am writing here. For example, I declare a statement or the integer variable n like this. This is statement 1. And in the second statement, I can declare the pointer variable int star P. At the time of declaration itself, I just want to initialize it with the address of n. Nothing wrong in it. It is perfectly valid. And somebody may think like this also. Can we write a statement like this? Int n comma star P is equal to address of n. Yes, this is also valid. Perfect. Why? Because first the memory for this variable n will be created. So okay, this is 100, and then the memory for this pointer variable will be created. This is P 200, and then I am assigning the value of address of n to this P. So here it will be stored. Therefore P is pointing to this. This is also valid. So either you can do it in 3 steps, or you can collapse it to 2 steps, or you can further collapse it to single step also. Everything is valid. Nothing wrong in it. Now let us take one more example. The same thing. Now I want to initialize the n also. Let me take the statement like this. Int n is equal to 10. So what happens here? Memory will be allocated. Assume the same address 100, and 10 is my value of n. Now I would like to do like this. Int star P. So memory will be allocated. Assume the base address as 200. This is P, and it is just pointing to air, a free space. Now I write like this. P is equal to address of n. So this P is going to point to this n by making the address of n value to be stored inside this P. Right. Now we can access the value of n in 2 ways. What is the value of n we have? We have n value as 10. When you want to access the value of n, we can simply access it by using the normal variable n, or we can access it by making use of the pointer variable P. So I can make use of the n to print the value of 10. I can make use of the pointer variable P, since P is pointing to n, right? That is the reason why we can also make use of the pointer to print the value of n, that is 10. But for printing the value, I am going to print the value here. Remember, for printing the value using the normal variable, you can directly use this n like this. As it is, you can use it. But when you want to print the value using the pointers, you cannot make use of the p directly. You have to make use of the indirection operator before this pointer. So star p, I read like this. As I told in the earlier session that this asterisk symbol can also be read as value at. So value at p. If this asterisk symbol is not given, assume that this asterisk symbol is not given. In such case, p is going to give the value as 100. P is going to give the value as 100. Why? Because p is storing the address of n, which is equal to 100. But I want value of n with the help of pointers. So I told that this concept, we call it as dereferencing pointers. Value at p means value at 100. So value at 100 is nothing but 10. So here the 10 will be printed, and here also the 10 will be printed. So the dereferencing is very important point, where you are going to print the value of the variables with the help of pointers. While using this dereferencing concept, you should be very careful that you have to use the asterisk symbol or the dereference operator before the pointer name. Very important point. So now I have got two things where I can access the value of 10 here by using the normal variable and by using the dereferencing concept with respect to the pointers that is pointed to that particular variable. So this is a generalized concept, very important point. Everyone should know the concept of dereferencing the pointers. So we are done with the integer value or integer pointers. Now let us see the character pointer. As I told that integer pointer is a pointer which is going to store the address of another integer. In the similar fashion, when I want to deal with the character pointer, I am writing here character pointer. So character pointer is nothing but a pointer which is going to store the address of another character. So it is going to store the address of another character. Or another character variable. For this purpose, I am giving the example. I declare a character variable ch and I assign a value of uppercase A here, single quotation. We know that when you are dealing with characters, you need to enclose the single character within single quotations. And now it's time to declare the character pointer, char star, let me take it as CP. And the third statement is CP is equal to, I want to store the address of CH. So I write like this. Simple thing. So here I have CH and here I have CP, and at this statement I am storing the address. Address is very important. Let me assume the address as 205 here, and this is 305 base address. And when I assign this statement, what it do is address of CH, which is 205, is stored inside this CP. So 205. At this point, this is pointing to this location like this. So this is how we need to declare a character pointer. And dereferencing, If I want to access the value of a here, I can do it using two things. One is by using directly the ch variable, or by using the dereferencing concept of star cp. Both of them will print a here. Now let us go with the third one, which is float pointer. So the float pointer is a pointer which is going to store the address of another floating point variable, another float variable. So here also I would like to give an example where I would like to declare a floating point variable. Float f is equal to some 13.5678. So here f, let me assume that the base address is some 1000, and here it is going to store 13.5678. Now since I want to deal with the floating point values, I should declare a floating pointer like this, float star fp, and I assign the address of f to fp. Very simple thing. So this becomes fp. Let us assume that the base address is 2000, and when after this we have pointed this one, so it is going to store 1000 here. Therefore we have a pointer pointing to this f. So when I want to access this 13.5678, I can do it using the normal variable f, or by using the dereferencing of the floating pointer variable. In both these cases we will get the output as 13.5678. So this is the normal things we can do with this integer, character and float. Now let us go into the concept of null pointers. Very important point that we should remember under this pointers concept is never ever leave the pointer without assigning the address. So never ever leave the pointers without assigning the address. So in the previous examples we have seen that we have, for example, if you take this cp, we have assigned the address of another character variable. If you take this floating pointer, we have assigned the address of floating pointer. Similarly, if you take the integer pointer, we have assigned the address of another integer variable. So anywhere when you are dealing with the pointers, remember that you should assign it with a valid address. But there are some situations where a pointer doesn't have a valid address to be assigned. So to avoid such situations, when you have a situation where a pointer doesn't have a valid address to be assigned to it, in such case you can assign a pointer, any pointer. You take integer pointer, character pointer or floating pointer, any pointer you take, that pointer can be initialized to a special value which is called as null. Remember to use this null to avoid the programming errors. You won't get any syntax errors, you will get logical errors. Okay. For example, if I take the integer pointer p, int star p like this, and for some particular point of time in the program I don't have a valid address to be assigned to it, so you should not leave this p as it is. If you don't have a value to be assigned, a valid value to be assigned to it, you can assign it to a null like this. Similarly, character pointer, char star cp, I don't have proper address of the character to be assigned to cp, so you just directly go to the null pointer assignment or null assignment. Similarly, you take floating pointer float star fp, and you assign it to null like this. So in all these cases we are assigning whether it is a pointer to integer, whether it is a pointer to character or pointer to floating point variable. We are assigning these pointers to a special value which is called as null. Remember that you should write it in uppercase letters only. So these pointers are pointing to a null value. They're going to store some null value. This is p and you have null here like this. You can make use of this p somewhere in the program, but right now I have assigned it a null value. So these pointers which have been assigned to a special value which is called as null is called as the null pointer. Now let us see what the void pointers are. We know that void is a special type of data type which is not pointing to some special value. That means it is not a integer value, it is not a float value, or it is not a character value. So when you want to specify nothing, then we are going to specify it as void. What does this void pointer means? In the previous discussions we have seen that an integer pointer is a pointer which is going to store the address of another integer variable, and a character pointer is a pointer which is going to store the address of another character variable. Similarly, a floating pointer is a pointer which is going to store the address of another floating point variable. So we have specializations in these pointers. That means the floating pointer can hold the same address of same type of variable, or the character pointer can hold the address of same type of variable. But when you want to store the address of any type of variable inside a pointer, we can declare a void pointer. So the syntax for declaring a void pointer is we make use of the void data type, and then let me take the asterisk symbol and VP. So VP is a void pointer here. The point here is you can assign this VP a value of or the address of another integer variable, or you can assign the void pointer with the address of another character variable, or you can assign the void pointer to the address of another floating point variable, or anything, arrays, you can make use of it, or the functions can also be the address of functions can be stored inside this void pointer like this. The point you have to understand here is that the void pointers have no restrictions on the address of the variable which it is going to store. But the specialized pointers like this integer pointer or character pointer or floating pointer, they are very specific to the addresses which it is going to store. So you may get a doubt that what happens if you store the address of one variable inside another type of pointer. For example, let me take the character pointer and let me assign a floating point variable like this. So here CP is the character pointer and F is a floating pointer. Is this type of assignment valid? Means it is valid, but you will get a warning here. You will get a warning. So to avoid these warnings, it is better that you write, or when you want to write a clean code, it is better that you always write or you always store the correct variable addresses in the correct pointers. So there should be a match between the address of the variable which you want to store and the type of pointer which you are making use of it. Very important. But the speciality of these void pointers is it can store, the void pointer can store the address of any other variable, whether it is an integer variable or character variable or floating point variable. This is the reason why these void pointers are also called as generic pointers. Generic in the sense it is capable of holding anything. It is used for general purpose. So void pointers are otherwise called as generic pointers. Now the next topic or the next concept what we are going to discuss is nothing but the pointer to an array. We need to discuss about the dangling pointers, but I am just postponing the discussion on these dangling pointers to our next session. We need to discuss some 3 important points regarding these dangling pointers. So we'll be discussing these dangling pointers in the next session. I just want to wrap up this session with a discussion on pointer to an array, pointer to a function, and pointer to a structure. So let me have this pointer to an array. In order to declare a pointer to an array, first of all you should have an array. Let me declare an integer array like this. Here A is an integer array which can hold 10 values. Now I want to declare an integer pointer that is pointing to this array. Since this A is an integer array, you have to declare the integer pointer like this. Int star p. Since this p is going to point to an array of size 10, I can write like this. So there should be a match here. And I am assigning the address of the array, which is the name of the array is A. I am assigning the address of A to this p. In simpler form, you can also write like this also, nothing wrong in it. Int star p is equal to address of A. This is valid and this is valid, but this is more particular pointer that specifies that p is a pointer that is pointing to an array of 10 integers. And coming to the next point of pointer to a function. Let me take a simple function which has a data type of void, and let me take the name of the function as display, and it is going to take one integer value as the parameter. So this is the declaration I have. So display is the name of the function, void is the return type, and integer is one parameter. Only one parameter it is accepting, and that too it is integer. Now I want to declare a pointer to this function. I know that we can declare the pointer with star p like this. But what about the data type of this p? Since the return type of display is void, I have to declare a void pointer. And since this is a pointer to a function, you have to make use of this parameter list also. So I write like this, and I assign the address of the function to this pointer. So this is how I should write. So void star p int is equal to address of display. Let me take one more example and assume that the return type of the function is integer and the name of the function is show. Let me take two values which it is going to accept. The first parameter is the integer and the second parameter is the float. In this case, if I want to declare a pointer, I take the pointer indirection operator, I take the pointer variable as p, and since the return type of this show function is integer, I should declare an integer pointer. And in order to make this p as a pointer to the function, you can write the data types of the first parameter followed by the second parameter, and then you make use of the assignment operator followed by address of the name of the function. So this is example 2, how to declare a pointer to a function, and this is example 1 of declaring a pointer to a function. And the last topic of our discussion is the pointer to a structure. Let us assume that I have a structure called student. I have defined a new data type struct student. In order to declare the pointer to this structure, I have to declare a pointer variable star p. Okay, p is a pointer variable, and it should be preceded with the new data type what I have defined here. So the new data type what I have defined here is the struct student. So I should declare it as struct student star p. At this case, p becomes a pointer of type struct student, and then you can assign the address of the variable of the structure to this p. So after this, I can have the second statement like this. It is struct student stud1. I have created a normal variable for the struct student. I have created a pointer variable to the struct student. This is statement 1, this is statement 2, and in the third statement I am assigning the address of stud1 to the pointer variable called struct student. So this is how we are going to declare the pointer to a structure. So that's all for today's session. Let me have a quick recap of what we have discussed in today's session. Today's point of interest, what we have discussed is the various types of pointers what we have in the C programming language. We started our discussion with the declaration of pointers here. So this one I have used. This one. After declaring the pointers, what happens in the memory location, what is the job that is done by the compiler, here we have discussed, and the allocation of the normal variable, memory for the normal variables, the allocation of memory for the pointer variables is also discussed, and the third statement is how we are going to assign the address of a particular variable to a pointer variable, and what happens after assignment of the address of a variable to a pointer variable. All these things we have discussed, and then we have seen the various shorthand forms of representing or the assigning this address of a variable to a pointer in this format. And here also we have seen the simplest form here, and we have seen the examples of how the values of a particular variable can be accessed. We can do it with two things, that is the normal variable, or by using the dereferencing concept, which is with the help of the pointers. And after that we have seen how we are going to declare a character pointer, how we are going to declare the floating pointer, and how we are going to store the address of character variable to the character pointers, how we are going to store the address of floating point variables to the floating pointers. All these things we have seen. And one specialized pointers what we have seen is the null pointers, and always remember the rule that never ever leave the pointer without initialization. So you should always initialize a pointer with some address, but there are some situations, unavoidable situations, where you don't have a valid address at that particular point to be assigned to a pointer. In such case, what you have to do is you have to simply assign a special value to those pointers, which is called as null. So when you assign a null value to the pointers, those pointers are called as null pointers. After this, we have seen another special pointers which is called as void pointer, which is also called as the generic pointers. The reason why it is called as generic pointers means the void pointer is capable of storing any is capable of storing the address of any other variable. So you can store the address of an integer variable inside a void pointer, you can store the address of a character variable inside a void pointer, or you can store the address of a floating point variable in the void pointer. Any address it can hold. That is the reason why we call it as generic pointers. And we have discussed that what happens if we store the address of another variable inside one type of pointer. That means if I want to store the address of a floating point variable inside a character pointer or integer pointer, you just end up in a warning statement given by the compiler. So the program will run, but you will get some warnings. So to avoid this, better always write your programs with the pointers. When you are dealing with the pointers, you always write it by making the initialization of the correct pointer with the correct address. Always have a good mapping of the address part and the pointer type. And we have postponed the concept of dangling pointers for the next session. And we have seen the pointer to an array, how we can declare a pointer and how we can store the address of an array. And we have seen how we can make use or how we can declare a pointer to a function. 2 examples we have seen, and finally we have ended up our discussion with declaration of a pointer for a structure. So we have seen the pointers for the fundamental data types, we have seen the pointers for the derived data types such as arrays and functions, we have seen the pointers for the user defined functions such as structures. Other than this, we have seen the null pointers and the generic pointers, which will be very useful in some of the programs. So that's all for today's session. Thank you one and all.